I would like to introduce NKV-550 to the esophageal pressure and transpulmonary pressure monitoring. Basically, this is what we have on our event. We have two apps. The first one is for the esophageal pressure we call auxiliary pressure. We have the app area on this part of the vent here, and then you can open here, and then you can select. There are two apps, auxiliary pressure app and transpulmonary pressure app. So this one here, we are showing for the auxiliary pressure, we are showing only the esophageal pressure, right? It's this guy here. You can see the waveforms, the numeric monitors on the top. And then the second one is the transpulmonary pressure app, this guy here. Let me stop the video. We can see the monitors here, transpulmonary peak pressure, transpulmonary mean pressure. I will go through all those monitors, but just to show this guy here, the transpulmonary and inspiratory pressure or transpulmonary plateau pressure, transpulmonary and expiratory pressure, and the delta transpulmonary pressure here. Basically, this is what we have on NKV-550 at this time here. How to use NKV-550 to monitoring esophageal pressure and transpulmonary pressure. Let's follow in this paper here that I think is very interesting to explain this. The first thing we need to prepare and check the system. Do the positioning of the catheter. You can use this way here. You measure the distance between the nose to the ears, and then to shift forward process here. And this distance should be somewhere between 35 and 40 centimeters. And then you pass the catheter inside of your patient. Inflated the balloon with the right amount of air recommended by the manufacturer. If you are using Nutrivent, 4 ml. If you are using Cooper, 1 to 2 milliliters here. And then now we needed to understand if the catheter is in the right position and if the amount of air we are using is the right amount of air based on the compliance of the balloon of the catheter. So how to know if the catheter is in the right position? We should do a occlusion maneuver or VID maneuver. This is the occlusion here. There are two situations. The first situation, your patient is totally sedated under controlled ventilation, right? And the second one, your patient is awake or your patient is triggering the ventilator, which means your patient has inspiratory effort. This is the second situation, your patient has inspiratory effort. This is the behavior. And here is in a controlled situation. Your patient has no effort. Basically, we can do the occlusion test for both situations. During the occlusion test, we are looking for the variation of the esophageal pressure or the swing of the esophageal pressure, and we are comparing with the swing in the airway pressure, okay? If the swings of both are very close, between 0.8 and 1.1, 1.2, your catheter has the right amount of volume inside of them, and it is in the right position. If the relationship between the esophageal delta pressure and the airway delta pressure is out of this range, less than 0.8 or more than 1.2, probably your catheter is in the wrong position and or your filling volume is wrong. Or we overinflated or we underinflated the catheter. Let me show you how to do this on NKV-550. For example, we already positioned the catheter inside of the esophagus. We inflated the catheter with the amount of air by the manufacturer. Now, let's do the positioning of the catheter. So we will do a occlusion maneuver here. So then we don't want the alarms kicking in, and we don't want the patient trigger the ventilator. Let's change the alarms here. We change the apnea alarm to 60 seconds, the minimum volume alarm to the minimum, which is 0.02. Change the respiratory rate to the minimum, 1 breath per minute, and change the trigger. We are increasing the trigger to be harder to trigger the vent. And now, let's open the auxiliary pressure app. The first thing we should do here is do an expiratory hold maneuver or an inspiratory hold maneuver. On this example here, I am doing an expiratory hold maneuver. Take a look. This is the app for the expiratory hold maneuver. We apply the hold, and at the same time, we do a very gentle compression at the chest wall of our patient. And then we can see the variations here. Here, we are showing only the airway pressure. So then, the next step, we frozen the waveforms here. We open the auxiliary pressure app again. Why you should open? Because when we frozen the waveforms, the app closed by itself. And then now we will compare the delta variation in the airway pressure with the delta variation of the esophageal pressure. Okay. Now I'm comparing airway pressure with the esophageal pressure. Okay. This is the pressure at the end of inspiration for airway and for the esophageal pressure. And now I'm getting the end expiratory pressure for airway pressure and esophageal pressure. Now I just needed to do the ratio. The delta airway pressure on this example is 5.1, and the esophageal pressure is pretty close, it's 5.2. When I do the ratio is 1.01, which means this catheter here is in the right position and inflated with the right amount of air. If the ratio is out of this range, probably your catheter is in the wrong position and or the filling volume is wrong, or we are overinflated the balloon, or we are underinflated the balloon here. Let's assume now on this example here, the balloon is in the right position and filling with the right amount of air, okay? And then I'm going to the clinical or the interpretation of the numbers on NKV-550. Let's assume we prepare and check everything is okay. Let's try to understand what the numbers of the transpulmonary and esophageal app it's telling us. Basically, this is the way we use the transpulmonary pressure. The most important is to understand the transpulmonary pressure at the end of inspiration and the transpulmonary pressure at the end of expiration here. So we have two apps, auxiliary pressure, transpulmonary pressure. Using both of them, using the holds. If you wanna know the transpulmonary pressure at the end of inspiration, you should apply an inspiratory hold maneuver, okay? And if you want to know the transpulmonary pressure at the end of expiration, you go there and do an expiratory hold maneuver. And then you have the numbers. The numbers will be here and here. This guy is the difference between transpulmonary peak pressure or transpulmonary and inspiratory pressure and transpulmonary and expiratory pressure. Okay, let me go through the EpiVent 2. The way they do is transpulmonary pressure at the end of expiration should be positive, greater than 0, which means no collapse. The transpulmonary pressure at the end of inspiration should be somewhere below 25 or 20 centimeters of water to avoid overdistension during ventilation. Basically, this is the way. Transpulmonary pressure app. Those are the monitors, right? Peak transpulmonary pressure, mean transpulmonary pressure, plateau transpulmonary pressure, and expiratory transpulmonary pressure, and delta transpulmonary pressure. Let me go through one by one here. Peak transpulmonary pressure, we are getting the maximum of the transpulmonary pressure during breath cycle, is the peak. In this example here, is this number here. This is under volume control with an inspiratory hold and an inspiratory pause set here, inspiratory pause of 0.5 seconds. Okay. The mean transpulmonary pressure is the mean of the transpulmonary pressure over 30 seconds. Plateau transpulmonary pressure or transpulmonary pressure at the end of inspiration. Here, I think this was one of the questions. To get this number in the app, we need to do an inspiratory hold maneuver, or we should set a pause during volume control. If you are, for example, in pressure control, you don't have the pause, and you don't do an inspiratory hold maneuver, here you will see dashed. So then if you want to see this number, you should go there and do an inspiratory hold maneuver and check the number. If you are in volume control and set an inspiratory pause, this number will be updated breath by breath, like here on this example here. This is my vent and this is the ASL. Let me do the maneuver for you. As you can see here, the plateau pressure is dashes. I apply the inspiratory hold maneuver here. And then now open the transpulmonary pressure app again. Freeze here, open the transpulmonary pressure, and then you're coming back here. See the plateau pressure here? Now it's 13.7. For now, this is the way to get the number. The same thing for the end expiratory transpulmonary pressure. But if you don't want to do this, for example, you are in volume control, you just need to set the inspiratory pause and then you have the number breath by breath. So the end expiratory transpulmonary pressure, it's automatically updated at the end of the expiratory for all breath cycles. This could be dynamic and could be in a static one. If you do an expiratory hold maneuver, you can go there and measure the end expiratory transpulmonary pressure at the end of the maneuver. And the delta transpulmonary pressure is the peak transpulmonary pressure and end expiratory transpulmonary pressure. This is the clinical application of transpulmonary pressure, why the transpulmonary pressure at the end of expiration should be positive, because when it's negative, this means lung collapse. And then when it's positive, we don't have collapse. For example, here we are showing the amount of collapse in many patients using EIT, electrical impedance tomography here. And here is the transpulmonary pressure. And here is the different levels of PEEP. When we don't have collapse, here the transpulmonary pressure is positive, and then when you have collapse, it's negative. So this is one case of the EpiVent 1. This patient has, this is the transpulmonary pressure waveform here. When you do an expiratory hold maneuver, you can see the transpulmonary pressure is negative, it's -6. And then you apply a recruitment maneuver or you increase the PP here, and this is what happened. Now at the end of expiration, your transpulmonary pressure is positive. And if you do an inspiratory hold maneuver, the number is 12, which means you're doing a protective lung ventilation use transpulmonary pressure based on their settings. They use this table here. So for this situation, when the transpulmonary pressure at the end expiratory transpulmonary pressure is 4, the FiO2 is 0.7. But now, let me go through some issues or some tricks of the esophageal monitoring and transpulmonary pressure monitoring here. The first thing is the position, right? If the position is, if the catheter is in the wrong place, the numbers are completely messed. And another very important thing is the amount of air to filling the balloon of the catheter here. The best way is to do a pressure volume curve of the balloon for each patient, right? Which means you pass the balloon inside of the esophagus, and then you do a PV curve for each balloon or each patient here. This is one example. This is the transpulmonary pressure at the end of expiration here. And then we can see the V minimum is the minimum amount of air you need to apply to your balloon to get the swing of the esophageal pressure. And then you have this V best. The V best is the amount of air where you get the maximum swing of the esophageal pressure here. And the Vmax is the maximum amount of air you can use without losing the signal of the esophageal pressure swing here. So basically, the recommendation is to do this for each patient you have. As you can see here, if you inflate with the difference between the V best and V minimum here, it's more or less 3 centimeters of water, which means if you inflate with more or less volume, you can have a huge difference in the absolute numbers of the swing of the esophageal catheter here. This is another way to show this. Here's the balloon recoil. The easiest way to do this calibration, I think, is like this. For example, you have a balloon, a huge one, that you can inflate with 9 or 10 milliliters here. And then you start with 0. You can see the variation of the pressure at the catheter. We put 0.5, 0.1. Now you can see the swing is higher than here because This is the minimum volume to get the swing of the esophageal pressure here. This is the V minimum. And then you inflate with 1 more milliliter, 1 more, and go, go, go. And then you can find here the V best is the amount of air where you can see the highest swing of the esophageal pressure for this patient. What is the problem here? Basically, you should do this manually. And then we have other problems here. This swing can vary with the amount of PP you're using for your patient. For example, if your patient is with PP of 10 or PP of 5 or whatever, the swing of the esophageal catheter can change with that one, as you can see here. And the noise is different here, and we don't know the right way to do this. Other points here, and why this happens, because when you have more or less PEEP, the position of the esophagus inside of the lung is completely different, or I mean inside of the chest wall. For example, and this one example we did many years ago, this is a pig, an experimental model of RDS with PEEP of 25. As you can see here, the esophageal catheter is in this position here. Here we have another pressure transducer here to measure the regional pleural pressure, right? PEEP of 20, you can see the position here, 14, 8, only to show this difference here. But basically, those are the limitations to monitoring this.